fundamentals of machine learning, where we explored the relationship between artificial intelligence, machine learning, and deep learning, along with complete machine learning workflow. Today, we move on to one of the most critical stages of that workflow, data pre-processing and feature engineering. Today's lecture will focus on feature scaling, data encoding, and data preparation techniques. Before any machine learning model can produce accurate and reliable results, the data must be carefully cleaned, transformed, and prepared. We will learn how to handle different types of data, convert categorical variables into to numerical form, scale features for improved model performance, and engineer meaningful features that help algorithms learn more efficiently. Data pre-processing is often considered the foundation of successful machine learning projects. Well-prepared data leads to better model accuracy, improved efficiency, and reliable predictions. The concepts covered today are essential for anyone working in artificial intelligence, data science, or analytics, as they ensure that machine learning models are trained on high-quality data. It is now my pleasure to welcome our esteemed mentor and speaker, Dr. Meher Chand, Associate Professor at Farid College of Engineering and Technology, Bathinda. Through his expertise in artificial intelligence, machine learning, computational sciences, and data analytics, he continues to guide learners with practical knowledge and an industry-oriented approach to solving real-world challenges. With great pleasure, I invite Dr. Meher Chand to kindly lead us into today's session. Over to you, sir.
Okay, dear Face, thank you for the nice introduction, and dear participant, welcome again in our ongoing workshop. And I hope that all of you are doing well, and the content which we are presenting are fruitful for you. Okay, if you are using, otherwise, you know. So just 1 minute, I am going to share my screen. So please let me know, did you cover the partial part which I have shared yesterday about the PPT? Some algorithms we were not able to cover due to the lack of time. But I told you that you must try to complete all these so that we can easily cover the next session. Okay. And secondly, there was one cheat sheet where we have some roadmap about the machine learning, what type of the skills you are required to develop, okay, and how you can achieve this goal. Okay, since without having roadmap to learn AI, we will waste our time. So this is the process step by step. Okay, if you are doing step by step and you know what type of the skills are essential and how you can achieve them. So these things are very, very important. Otherwise, our goal will be very far away. Okay, so at least we must be familiar about the skills which we are required. Okay, so today I am going to share my screen first, then just 1 minute. Okay, and this is the Jupyter notebook. Yes, this is the Jupyter notebook. And in the Jupyter notebook, I have download directory. Actually, there is some problem in my mouse. Okay. Here is data set related to health. And this is the lecture. The topic is data pre-processing and feature engineering using the healthcare. Okay, so this topic, this part we are going to cover, and after that we have some algos which you will implement. So yesterday, this part we have discussed in theoretical part through the presentation. Okay, and now we have to implement the same thing by using Python, how we can do. Okay, so here you can see this is the file uh, containing some data set. Okay, just 1 minute. I want to make it in full size using toggle zone. Yes, I think now everything is fine. So you can see these are the basic libraries which we are required. Okay, and pandas as pd, numpy as np. Then we have train underscore test underscore split. Okay, then we have the skill learn processing, one hot encoder, level encoder, standard scaler. Then we have the simple imputer, column transformer, pipelines, random forest classifier. So last one we have the model, random classifier. Okay, so here you can see we have some data set. Okay, we have some data set. Create the sample healthcare data set, as you can see here. Okay, and when we have to execute this one first. Yes. So here you can see this is the patient ID, age, gender, blood pressure, cholesterol, BMI, and smoking, diabetes, disease. So here you can see the heart disease healthy and healthy. Okay, some are healthy or some have heart disease. Then we can have the diabetes, and yes, no, the options are there. And similarly, we have the smoking, and here cholesterol, we have one value is missing. Nan means not a number, and here is also you can see nan. So when in your data set nan appear, it means this is the not a number. The values are missing. We have to control this type of the data. Okay, so here you can see the data set is very small, and the same we can implement for the large data set. Okay, by importing the CSV file. So here first here we have execute, then first we are required to convert this about data set into data frame. So dictionary we have used in the very previous sessions, and by using the dictionary we can easily create the data frame. Okay, so if you have the data set in your CSV file, just you are required to import as we do in the previous session, and after that directly we can use. But if you have your own data set and you are required to create data frame, so for that we have to use which library? Pandas. Okay, so can I have some questions from you? I shared today some few minutes ago one questionnaire, so you should reply there. Only 10 participants reply there. The other did not reply. So I want to check whether the things which we are presenting are going well or not. Okay, so um, similar type of the questions will be also during the session. I will share with you. Everyone, you are required to submit. Okay, I give you 1 minute. Those who did not do right now, please submit the questionnaire. Only one question is there. You need to require only the submit one appropriate answer from the question. Do it immediately. Only 1 minute. The link is available in the WhatsApp group, and do immediately. Okay, I hope you have done. Okay, so I will check later. Here you can see we have the uh, data set, okay, which I have shown you at this place. So by using the dictionary, we have created this data frame. And when I will execute, sorry, this is the problem with my mouse. More active, control and enter. Okay, so this is the same data. Okay, now the entire data is stored inside DF. DF means data frame. Now we can have some basic operations, and you all are familiar about all these, just like info, disport, describe, is null. So export the data, because before using for any kind of the operation, our data set must be clear. So someone mic is unmuted. Please, dear participant, keep muted your mic if it is not required. Okay. So here, control and enter. You can see the info. Here, the in this column you can have the patient ID. Okay, then we have the null data. These are the some column name. Okay, these are the column names. At heads are there. No null shell. Okay, all the shell contains some value. Okay, so here 5 entries are there, 0 to 4, and these are the some values. Okay, and here this is the, you can see patient ID, and here we have the gender, and these are some unique values you can see here, unique values, and some are appears like an n. See the because here we introduce all the values. So when you will check it, you can see from uh, mean, STD, and minimum value 25%. If you will do here, not all. Okay, this will be fine. Okay, we should use like in this way. So only we can get the descriptive values for parametric values. Okay, now it's fine. The count, you can see the count, the mean, STD, minimum value, 25%, 50%, first quarter, second quarter, etc. Okay, then also there is one this operation. Okay, so here is null dot sum. Okay, so this will return how many, just like you can see in age group there is one value missing, cholesterol content also one value missing. Okay, you can come back here, see the data set. Okay, here this is the age group, one value is missing, and in cholesterol we can have one value is missing. Okay, so in this way we can count all these. Then after handle the missing values. So what this will do, number of columns, just like we can have age, blood pressure, cholesterol, BMI. Then what we do, we will use the simple imputer. Simple imputer, this package we have installed here, which will be used to handle the missing values. Okay, so what technique we are using here? Take the median. Okay, just like you can see here in this data set here. So this is the unknown value, missing value. We want to fill this one by taking the mean of the other values or median of the other values. Similarly, here in this column, we can take a median, we can take a mean, we can take standard deviation. Okay, we can take the highest frequency or repeated value. Okay, backward and forward according to our choice. Okay, so you can use any technique. Several ways are there. Here we are using median. Okay, then imputer fit transform, a new column, and df is null sum. So see here, when I will execute, sorry, this is the problem with my mouse. Yes, control and end. So when you will apply, you can see now all the variables don't have any missing value. All the zero there you can see all are zero. So the missing value has been covered. We handle the missing value by using this operation. Okay, so this value has been taken and this store inside imputer. The imputer value is used to fill the missing value. Okay, got the idea? So in this way, you can check it, and whenever you have any new data set and you are required to handle this type of the value. So this is the example. Okay. Such type of the example we did not discuss in the previous session, but the operation we are familiar. But in our all the examples which we discussed, there was no missing value, but in this data set we have missing value, and you have the example how you can handle it. Okay, then we are required to encode target variable. Okay, we are required to encode the values. Okay, so here you can see this is okay. So come back here. This is the disease. So some are healthy and some are heart disease. So actually, when you will apply some static or the machine learning model, these are not important for us because uh, algorithms understand only numerical values. So we have to convert these values in 0 and 1. Okay. So this will do automatically. This will do. See here. Sorry. This is happened due to my mouse problem. So when I will execute, control and enter. Sorry, once again, control and enter. See now. These are in true false. Smoking, true false. You can see here disease. Okay, this is the disease column. Okay. Here also gender well, true false, and smoking, yes, no. That is also true false, and diabetes, yes. Okay. So these are due to you can see one hot encode categorical feature and gender, smoking, and diabetes. Okay. So for that we are using drop first, then true. So see the data set, and according to this statement, what happened? Okay, so you can see here smoking, yes, no, and here is also same. So this will convert to the data in true false. True false also a program can understand. Okay, because these are the logical values. Okay, so here you can observe smoking also you can observe, and the here is are the disease which we encode in 1 and 0. Okay, so here you can see the last column, diabetes, yes. Okay, so then after we have the standard numerical features, and when we will apply here, control and enter. Okay, so standardized and numerical feature. What are the meaning of this one? See the values here. You can see cholesterol, BMI, age, blood pressure. Okay, so by using the standard scalar, now the values you can see are in very small size. Okay, we apply for all these parameter: age, blood pressure, cholesterol, BMI. So you can see this BMI, cholesterol, blood pressure, age. The values has been decreased in size. Okay, by using. So here actually we have function minimum, maximum. So that function is used here for the scalar. Okay, so actually we fix the values in very small. Mainly these will lies between near about to zero. Okay, as much as possible as we can do. And then after we can have feature engineering. This is the feature engineering. Okay, so can you please let me know anyone? Yesterday we talked about feature engineering. So anyone please? Can you please explain? You can take any example from your side. See here BMI category. Okay, body mass index. So if the weight is less than 18.5, this is underweight. Isaac, please keep mute your mic. Please mute your mic. If there is no question, okay. So here what we do.
What did you? I've done double. That's the second one I've given him. Hey, who did I call that? What's that man doing?
1 minute, 1 minute.
Where do you?
Please, 1
It's
minute.
not finished. I look for bomb. That's not like coffee. The first time, 53 came to see. 53.
Okay. Sorry for the interruption. Now you are not permitted to unmute mic. If you have any question, you can raise your hand, or either you can put your question in the chat box. Okay. So here you can see we can by using the feature engineering, sometimes if we divide the data in the group, okay, or sometimes we are required to introduce new value. For that purpose, we are using feature engineering. And by using the feature engineering, we have non overfitting outputs. Accurate, we can increase the accuracy, we can reduce the complexity of computing, and many more. Okay, so here if the weights are under below 18.5, this is the underweight. If the weight is greater than 18.5 but less than 25, this is normal weight. If weight is greater than 25 but less than 30, then this is overweight. And otherwise, if weight is greater than 30, okay, that is obese. Okay, so these groups we have. And after that, here we apply PD.cut, BMI, and these are the bins, and we will visualize in this way, which the group which we have created. Okay, and also here we have the hypertension, high cholesterol, risk, etc. So these are also introduced here according to the blood pressure and cholesterol, the values which we have. And when you will execute this shell, this is the problem. Okay, control and okay. DF cut level base. Okay, BM category. Yes, DF dot head. Okay, so these are some more parameters has been introduced, and you can see we have the new data set. Okay, so where you can find underweight, normal, or fit, obese, we have some new column. So for that, we have to scroll in this direction. Yes. So here you can see hypertension. Okay, NP dot where blood pressure is greater than 0.510. Okay, so and then we have the high cholesterol. Okay, if greater than 0.51. Okay, and then we calculate here risk score by adding hypertension, high cholesterol, and smoking, and S type as integer. So these values are in integer form. Okay, and high cholesterol also we have calculated here. These are the hypertension. Okay, and BMI category, which we create by using this value: underweight, normal, or fit to obese. Okay, so these are inside BMI category. Okay, so this is the variable name, and you can see here. Okay, normal or overweight, underweight, normal, and these are the other health conditions. Okay, so this is the feature engineering. This will make you more understandable, and some more insight we can get by using this. Okay, then after, as we discussed yesterday, how we can implement a machine learning model. Okay, so for that, we have to divide our data set in two parts. Okay, so one will be just like output value or the target value, and target value is here disease. Okay, target value is disease. So in the case, in the disease variable 11010, you can see. Okay, so these are the disease, whether yes or no. According to that, we have 11010, and the x variable will contain other parametric values, because on the basis of the parametric values we can predict disease. Okay, so here we have to use df dot drop disease, because this is we are using for y variable. This is the target value. So in x we are not required. Patient ID is useless. This is not concerned with the disease. And BMI category. Okay, BMI category, this column you can see here, which we have created. All others are numerical value or true false also, because if true 1 and if false 0. Okay, so these are also we can use, but this type of the string type data, no numerical values we are not able to use. Okay, Boolean values we can consider, we can use. So the values which are not part of the input data. So X will contain only those parametric values which are the independent and input argument for Y variable on the basis, because if there is a disease, for that we have some numerical parameters are there. Some parameters are there which we are required to test. And after testing, we can predict, yes, this type of the disease is there. In the same way, Y is the target value. And target value is saying that whether disease or not. Okay, so that is inside Y, only the disease variable. And in the X, we have all the other variables having the parametric values. Okay, sometimes patient ID can be numerical value, but not associated with disease. This is only the identity for patient. Okay, and this BM category. So this type of the column which are not useful, we can drop them. Now we have the data which can be in two variable. If you want to check the variables, I cut this part from this place and I'm using in new one here. And here what I do, I will do here. Sorry, this due to my mouse, very irritating from. So here you will use x dot head. Okay. You can see. So in this X, you will see that this is patient ID, BMI are not there. You can check it. Okay. And then if you are using here Y head, Y dot head. So only these values are there. Okay. These values means only disease. Only disease. One variable. Okay. So as you can see from this very small data set, and you can easily understand now, the data is divided in two parts. One is X and other is Y variable. After that, we will apply our model. And this technique will be always same as we discussed yesterday. Okay, so X test, X train, X test, Y train, Y test is equal to train underscore test underscore split. Then in parentheses, X variable, comma, Y variable, comma, test size, which is 0.2. Then random state, you can take any value, which is greater than any integer greater than 0. Okay. Most commonly, we are using 42. There is some history why we are using the 42, but there is no impact if you are taking any value. You can take 40, you can take 55, you can take 99, any value which you need, which you think. So, but we have to assign some value. Okay, so then after we have a print x trend dot shape and x test shape. Okay, so we can have, see, the data is separated in two groups. First is 4,10. 4 entries are there, and for the testing, there is only one row. Okay, because the data is very small. There are only 5 entries. Okay, so actually, this is only the purpose is that you can easily understand how all these things are happening. And once the concept will be clear, then you can handle any type of the large data set. Okay, because concept is clear, so the numbers doesn't matter. Matter is how you will apply. If the concept is clear, we can do. Okay, so this is a very small data set and you can easily catch all the values, all the outputs. Then after, we have the pipeline example. So here we have the some numeric feature, just like age, blood pressure, cholesterol, BM, and other is a categorical feature, which contain gender, smoking, diabetes. Okay, so we will recreate the original data frame by using for the pipeline demonstration. Here you can see we are handling here PID data frame, and this is the age group. Then we have the gender, male, female. Then we have the blood pressure, okay, cholesterol, BMI, smoking, yes, no, and diabetes, yes, no. And these are the target. Okay, target means these are the Y values. These are the Y values. Okay. Previously, if you will, this is the raw data set. Okay. So these are the target values which we have convert. Okay. So some of the original data set we change some values, and now we have the pipeline. You can see the same process which we have discussed. Okay. So we are required numeric transformer, pipeline, imputer. Okay, if there is any missing value, simple imputer we are using median. Okay, then we have the categorical pipeline imputer we are using here most frequent. Okay, and one hot encoder drop first. We are always use drop first. Okay, then we have the preprocessor. So these are the same steps which we have discussed. Okay, so here column transform. So numeric transform, numeric feature. And in CAT, we have the categorical transform and categorical features. Okay. And in the pipeline, preprocessor, then classifier. Okay. For that, we are using random forest classifier. And when we will return this pipeline, created and model trained successfully. So here we will fit raw and target both. Okay, so you can see we have the raw data set and the target. Okay, and when you will execute, where is the raw data set? This is the target. Okay, and this is the raw data set. Okay, so in that case, we are applying, and when you will, sorry, control and so you can see here pipeline created and model trained successfully. Okay, so this is the process which we have applied here, and pipeline is created. Now the question arises here, why the pipeline we are required to create? Okay. So can you please, anyone? Can you please let me know? If you know about the pipeline, how we can use it, and what are the purpose of the pipeline to use here? Yes. Any line who are working in machine learning? Okay. So as you can observe this, the entire process which we do here. Okay. So actually the pipeline is a sequence of the data pre-processing and machine learning step that are executed automatically in the correct order. Okay, as we have applied here. Okay, so this will automatically execute in a correct order, and it help organize the workflow, prevent data leakage, and make the code cleaner, reusable, and easier to maintain. Okay, so here in this example, just like a patient arrives, medical history is collected, vital signs are measured, blood tests are performed, doctor review the result, diagnosis is made. Okay, so all these will happen in a sequence. So in the pipeline, the steps which are involved here, very first is the raw data. As you can see, we have taken here raw data. Okay, this is the first step. Then we handle the missing value. Okay, and in our data set, you can see here is missing value. By using, you can see median. And also the same thing we have done in the previous part. Okay. Then encode the categorical data set. So this is the process how we can encode the categorical data, just like true, false, or other string type of the information, how we can do. So this will automatically handle this type of the problem and scale the numerical feature and then train the machine learning model. And last one we have is the prediction. Okay, so this part we have to implement. Okay, so is there any more question? So here in this session, we discuss only how we can separate the data. So here also you can see we separate the data and the same process which we apply at this base. Okay, you can do here, but first for this data set. Okay, and by using the pipeline. So this will help you to use to clear the data set and how we can use the pipeline. Okay, so this is all about the today's session. And one more thing, the roadmap and the presentation which I share with you. So some of the algos we are not able to discuss. Okay, so you will complete the presentation so that when we will use these algorithms in the coming session, this part will be there as we do right now, and the advanced part will also will be there. Okay, so all the parts we divide in the small parts, and when you have the big complex problem, so that this small part can easily compile or we can combine them to solve the big problem. So if there is any complex problem, divide in the small parts. So these parts which we are discussing, we are presenting in a small part. So all these will help you to implementation of the machine learning model. So this is also the part of the machine learning. Okay. So I can permit you to unmute your mic. Yes. So if there is any question, please. Okay, recording lecture will be available after the session. I will share with you. Yes. Yeah, actually, I will add the remaining lectures in the playlist. Recording is there, but if all the lectures are in the playlist, so that will be fine. So that whenever you need to use in the near future, so all the lectures according to the session wise will be there. Okay, and you can use. Any more question? Train model not successfully, then do. Okay. Actually, after the training, there is a testing part. Okay, without having the testing part, we are not able to say whether the model is trained or not. Okay, when you will apply the machine learning model, that will always train, but depend upon the accuracy, how much. Okay, we are required the accuracy more than 90, or if possible, about 99% or plus. Okay, so if the training is about 70% or 80% or 90%, so this will let us know how far is from our target value. Okay, the 70% is saying that we are 30% away from our target value. If you have the accuracy percentage is 80, we can say that 20% we are away from our target value. If the accuracy is 99% or more than 99%, we can say we are approximately 1% away or less than 1% away from our target value. Okay, so these tests are very, very essential. And without applying these tests, we are not able to predict whether the model is accurate or not. So the accuracy and then testing, two things are very, very essential part to test the model. Okay, which we will do in the coming sessions. So we are applying everything step by step. Okay. If any more question. So, okay, thank you. So dear participants, this is all about the today's session. And tomorrow we will resume at the same time. I would like to invite Mr. Faiz over to you. And the file which I present right now, I will share with you. Okay, you are not able to unmute your mic? Just 1 minute. Give me 1 minute.
Yes. As we conclude today's session, I would like to extend my sincere gratitude to Dr. Meher Chand for his insightful lecture on data pre-processing and feature engineering. Today's session highlighted the importance of preparing data before building machine learning models. We explored key pre-processing techniques such as feature scaling, data encoding, and feature engineering, gaining an understanding of how these steps improve model performance and ensure more reliable, accurate predictions. These concepts form the backbone of every successful machine learning pipeline. I encourage everyone to revisit today's demonstrations, practice pre-processing different data sets, and experiment with various feature engineering techniques. Mastering these skills will help you build more efficient and robust machine learning models in the future. I would also like to thank all participants for your active participation, thoughtful questions, and continued enthusiasm throughout today's performance session. Your dedication and eagerness to continue to make this training program both engaging and rewarding. Thank you all for joining us today. Have a wonderful night, and we look forward to seeing you in the next session.